Thank you for inviting me. It's quite a big room, and I'm here to learn from you all. RISC-V is the industry standard ISA that expands opportunity. Let me start by discussing a little bit about the word standard. Standards accelerate innovation in our world. Standards are publicly available documents that everybody can rely to and can use to build innovative products. Think of, very simple, the USB. It's simple, but the document is really important. Everybody builds USB products starting from the standard. Think about Wi-Fi or Ethernet or the World Wide Web. These are all very important standards that are now pervasive in our lives. So a standard is available to everyone to start from and to build innovation on. RISC-V is the instruction set architecture that is based on the open standard. It means that everybody can access our instruction set architecture and can build processors based on RISC-V. There are no licenses, no royalties, no obligations. It's released under the Creative Commons license. RISC-V International is the non-profit association that pulls together all the companies in the ecosystem that are working on RISC-V. Our role is to ensure a positive, constructive collaboration and environment for all the companies and individuals interested in working on RISC-V to work together, contribute, and grow and progress on the ISA and build better products. Today we are funded by more than 4,000 companies, academia, individuals. And you can see the numbers is from IP vendors to chip vendors, software companies, and a lot of academia and individuals. So I was mentioning standards. So the key point is that RISC-V focuses on the specifications of a processor, the registers, the opcodes, the bit fields, the operations. And then everybody in the ecosystem can build products. So some companies, and you will hear over the next today and tomorrow, there are companies that build intellectual properties and build optimized implementations of RISC-V. There are companies that build silicon. There are companies that build products. And so as RISC-V, we are neutral. We support all the companies that are developing on RISC-V. The very first and simplest way and fastest way to be introduced and start working on RISC-V is to access our online catalog of free online courses. All the courses, or almost all the courses, are free. You can take them from your computer directly. I would recommend one. I've taken a few. I would recommend one that is building a RISC-V CPU core. I think every single software engineer should take the course and learn how to develop a very simple RISC-V core. RISC-V has an incredible market potential. How do we know? Well, there are no royalties, no license fees. So how do we know the progress and the deployment of RISC-V? Well, we can leverage what the companies share with us about their shipments, and we can work with analysts and their predictions. The SHD group has been working on analyzing RISC-V for the last several years, and this is a preview of their latest report that has just been released. And their prediction is that by 2031, RISC-V will ship 20 billion SOCs in 2031, and every SOC will have multiple RISC-V cores inside. And this is moving from an estimate of about 2 billion chips shipped last year in 2024. Let me mention that there's a blog post on our website, and there was a keynote by NVIDIA last October at our RISC-V Summit. And NVIDIA disclosed that every single GPU contains between 10 and 40 RISC-V cores inside. And so by doing the math, they estimate that they shipped about 1 billion RISC-V cores, just NVIDIA, in 2024. And you can find the keynote on YouTube on the RISC-V channel. So I invite you to watch it. The same report by the analyst predicts that by 2031, RISC-V will be everywhere. And depending on the market segments, there will be a market share between 26 and up to 39% in the various markets. Companies are investing in RISC-V for long-lasting success. Countries are investing in RISC-V because they need to define and build their strategy of technical and digital sovereignty. And these days is even more important than ever. Countries need to invest in RISC-V because they need to build a pool of talents, a pool of students, brains, expertise, and overall technology in their countries. Thanks to RISC-V, they engage globally with all the other countries across geographies. Multinationals are investing in RISC-V. They need to control their future. They need to be free from a specific vendor lock-in. They need to be able to innovate and introduce new business models. Researchers in academia, well, RISC-V has roots and DNA in academia. It's coming from UC Berkeley from the early 80s. That's when the RISC momentum started. And if we are here today, and thanks for highlighting the strong engagement with students and students worldwide, it's because academia is bringing a lot of energy and innovation to RISC-V. And the fact that you can start from a RISC-V implementation, from a public specification, and you can easily build your products, but even your master thesis, that's incredible. And sometimes these days I'm quite envious of the students these days, of what they can accomplish nowadays at university. And of course, startups. Startups start from everything that is being invested by academia, by the countries, and they can very easily add their innovation on top of the RISC-V specifications. And if you think about it, this is exactly why we are here today. This is why a few years ago, NASA and ESA and the European Union have been investing so much in products and innovation based on RISC-V. It's exactly for all these reasons, to involve all the students, to build innovation, to have a tech sovereignty strategy, and to be able to be free and open. So today and tomorrow, you will hear from all the speakers about all the challenges and opportunities in space. And yesterday in the meetup, Roland gave a very interesting talk about some of these challenges and how to mitigate the risk. So you will hear about building products that are radiation tolerant, and there's a lot of implications in redundancy, in error correcting codes, in software that runs also tolerant to faults. But there's also an angle of processing, high performance computing, AI. These are things that nowadays you need to run inside the product itself, at the edge. And of course, you also have requirements of being low power and being very fast and reacting in real time to external events. So RISC-V allows you to address all the requirements. The open compute architecture of RISC-V allows you to select the configurations and build your cores, or select cores from many of the IP vendors based on your requirements. And the performance can scale from tiny microcontrollers up to supercomputers. And the flexibility of the architecture allows you to scale the number of cores in your products depending on your needs, from a single core to hundreds of cores in a chip. And you can select the different capabilities of RISC-V, of the extensions to the architecture, so that you can get your real-time requirements, or you can get the right strategy and infrastructure to report all the errors logged by the hardware. And the other key important aspect is that given the openness of the specification, it's easy to start developing your custom extensions for your specific workloads and meet your performance requirements. The value of the open compute aspect of RISC-V means that we can all collaborate, means that we can share the cost of development for those innovations that are non-competing but are advancing the entire industry. I mentioned the customization. I like the concept that you identify your workloads, you analyze them, and you identify either the performance bottlenecks or the functional gaps. And once you analyze them, that's where you can start innovating. That's where you identify that you may need a different interrupt controller, or you may need a new vector instruction that will boost some of your computation. And this is where you can add it in RISC-V. And of course, the important thing is that then you share with your peers and you upgrade and improve the standards. So if you think about it, we are entering the era of a workload design silicon. You focus on your workloads, you focus on your products, on what you need to achieve in terms of computation, performance, functionality, and you can design the entire chip, and including the instruction set for those specific requirements. So RISC-V is modular. It can be daunting. So we start from a very simple instruction set architecture with about 40 instructions. You can do all the basics. And then over the years, we have been all together, thanks to the contribution of all the companies involved, we have been adding extensions to the instruction set. So new instructions like floating point or vectors, or now we're working on matrix. But also extensions that are improving the functionality of a RISC-V core, like extensions to new innovative interrupt controllers. So all these are the extensions that we all together ratify and use to adopt to evolve the standards. And then, with so many optional and modular extensions, it's important that we also avoid unnecessary fragmentation. So for a custom, fully vertically owned product, RISC-V gives you the flexibility of specifying exactly every single bit, like handcrafting your chip, and getting in exactly the functionalities that you need and removing everything else. And then you have the smallest possible design that fits your needs. But that's unique to you, and you carry the cost over time of maintaining it. On the other side, when you want to run a standard software like operating system distributions, you need standardization. And so this is where we introduce the concept of profiles. So we define families of RISC-V processors, and for each one, we define which specific extensions are required for that family. So if you want to design an application processor and run standard operating system distributions, then we think that you need certain functionalities, certain interrupt controllers, certain extensions for security, for atomic operations, support for hypervisor, support for vector processing. On the other side, for a microcontroller, maybe you don't need the MMU, but you need a physical memory protection unit, or you need a fast interrupt. And so this is how we build these profiles. So we list all the modular extensions that we think are mandatory for a family. And then the next step, today we're working on the server platform with many of the companies involved. So standardizing what goes around the core itself. And many of the companies working together, especially with the operating system vendors, they think that they need the same interfaces between hardware and software for an IOMMU, or the same hardware and software interfaces between the chip and the bootloader and the secure firmware and the operating system. So this is where we move from profiles to platforms. And platforms get closer to the specific industry verticals. And so you see server, automotive, embedded, edge AI. Each one may have different requirements for the overall core subsystem. And the next step is enabling all the software ecosystem on top. So I mentioned the RV823, that is the application processor profile, which we ratified last year. And the goal is to bring application binary compatibility across all the RV823 application processors. And we also mandate important extensions like vector and hypervisor. Overall, last year in 2024, we ratified 25 extensions. I can organize them into 3 buckets: improving performance, improving security and resilience, and improving overall functionality and debugging and tracing. For 2025, this year, our priorities are around the vector intrinsics. This is really important because it allows to integrate all the vector operations seamlessly in mathematical libraries. We are focusing on the matrix extensions, and matrix operations are very important for AI and HPC. And overall, we're working on improving the documentation around security up to confidential computing and supervisor domain isolation. And I mentioned the work ongoing on the server side. Hardware without software is not doing much. So we need to enable the entire software ecosystem. This is like an eye check chart. You can zoom in on the website. The message is that we need to collaborate with so many companies in the software ecosystem and have it ready. And this is where we work very closely with our sister organization, RISE, the RISC-V software ecosystem. And RISE is pulling together companies that need to port, test the full stability and optimize the performance of specific libraries, functionalities, workloads for specific projects. For example, RISE has been working on a specific optimized Java port for RISC-V or porting Python. They're also releasing regular guidelines on how to operate at software optimization level. I would like to leave you with some thoughts on the automotive SIG and whether this can be a model for RISC-V in space. In the automotive space, there are many requirements that are closer to what we will be discussing in this workshop. Requirements of safety, redundancy, requirements of real time, of performance, but also needs to address an heterogeneous architecture where you have in the same products, in the same platforms, you have microcontrollers, but you have also edge computing, and you have central computing, and you have AI acceleration and high-performance computing. So, as I said, RISC-V can address them all. Last year, Infineon gave a keynote at the RISC-V Summit, and Thomas Mohm mentioned that one of the values that Infineon finds in RISC-V is that the same ISA can be used across the entire architecture of an automotive platform. And Infineon announced that their automotive roadmap is based on RISC-V, from tiny microcontrollers up. The same ISA can be used in the AI accelerator, in the ECU, the electronic control, and the engine control unit. So we set up an automotive SIG. And the role of this special interest group is to gather the requirements from the automotive space. And looking at all the requirements, you map them to the available extensions and functionalities and characteristics of RISC-V. So this mapping allows to look at the requirements for a tiny ECU or a zonal controller around the edge of the car, or the central compute. And you have different requirements in these three areas of a car. And so the automotive SIG and the engineers from all the companies involved are looking into all these areas. For a tiny microcontroller, you need real time, and you need very fast interrupt controllers. For a zonal controller, which is maybe at the front of the car near the radar and the LiDAR and the cameras, you need AI at the edge of the car. Or in the central compute, you need to integrate software from many different suppliers, and all these software libraries shall not interfere one with the other. Or when one supplier updates their software release, but not the others, you don't want to reintegrate and revalidate together software from many different suppliers. So you need a robust isolation and sandboxing. So the automotive SIG is gathering all these requirements and mapping them and to what RISC-V is offering, and analyzing whether there are opportunities to innovate, to improve, add new functionalities or new security features, or maybe improve the performance. And so the goal is to come up with this gap analysis. So far, so good. And the opportunity is also to write white papers that will explain how to use RISC-V in these buckets. So my suggestion and my call to action from these 2 days of workshop is to consider whether there will be an interest starting from all the availability from the ISA, from the extensions, from the innovation coming from the entire RISC-V ecosystem, bringing together all the requirements from space. And this is where you are bringing the expertise, and we are learning from you. Look at these. Let's work together in doing this analysis. And I think this is already ongoing in many of the talks from today and tomorrow. Let's look at this gap analysis together. And is there an opportunity to have a space special interest group working all together and accelerating innovative products? And I would like to leave you with an invitation to see you all in a couple of months in Paris, where we will have our RISC-V Summit Europe. Thank you.